So only one person found a mistake. What number was that?
Number 3.
Number 3 on try trig 3. The answer was wrong. So since Higo was the first person to notify me, then he gets the +1. So the answer was supposed to be what? Root 55/7.
Yeah.
Let's put that on the board then. Try trig 3, number 3. That means only one person actually tried the homework. Strike 1!
Wait, in the video you said no bonus points for that.
No bonus points? How come?
I don't know, you said it in the video.
What video?
The homework.
Why did I say no bonus points?
Yeah. I swear.
I know, but why did I say?
I don't know.
Try trig 3, number 3. The answer should be root 55/7. I kind of remember that from last year. So change that. Or, all right, so today we start, this is the last chapter we're going to cover for the first semester, polar coordinates. Now I know for a fact that this is probably, this and logic probably are the only two things that you didn't cover last year. So now you can really have, except the other class told me that Mr. Rubash did like a optional thing. Did you guys actually learn it? Optional means don't do it. I'll remember that for your college recommendation there. All right, so right now we only know the rectangular coordinate system. Like, how do you locate points in the Cartesian plane? X and Y, right? So like, for example, if you have X and Y, then X tells you how much to go this way, and Y tells you how much to go that way, right? But is that the only way we can locate points in the Cartesian plane? No. We have, so this is called the rectangular coordinate system. So we have this other one called the polar coordinate system. So in the polar coordinate system, instead of labeling a point xy, we label it r theta. R is how far you are from the origin. Some people call this the pole. Okay? Like if you're doing the polar coordinate system, they call the origin the pole, but I just use them interchangeably. And theta is the angle that this segment here makes with the positive x-axis. So we can locate points in the Cartesian plane the same way. Now you might be saying, well, why do we need to do that? That's because when you get to calculus, some computations are easier if you change the coordinate system. And then when you get to 3 dimensions, which we're going to do next quarter, then we have 2 other coordinate systems. So you got to get used to this one first. So the first thing you have to learn is you got to learn how to plot points. Just like when you first learned the rectangular coordinate system, what, 6th grade, 7th grade, isn't the first thing you do, you plot points? And the teacher made a worksheet and then you connect the dots and you get a picture? Yeah, but we're not going to do that, okay? So, if you look at your notes over here, this is what polar graphing paper looks like. Right there. So instead of rectangular grids, like, you know, regular graphing paper, this is what polar graph paper looks like. So one of them is in degrees and the other one is in radians. Now you might be wondering, well, how come they have all these concentric circles? Because that makes it easier to plot points. So if you wanted to go on the internet and download some polar graph paper, just type in polar graph paper, and I'm sure there's places where you can just download it for free. But see, I gotta train you for calculus. Everything is done freehand now. Don't use graph paper. So polar graph paper is basically all of these concentric circles. Ew, that's kind of terrible what I did there. That's why you have this graph paper there. But you got to practice doing it freehand. Okay, so let's start graphing points. So how do you plot the point 2 comma pi over 4? So what does this mean? The point is 2 units from the origin, and it makes an angle of pi over 4 with the positive x-axis. So what I like to do, I rather measure off the angle first, right? So remember, this is 0, trigonometry, right? And the positive direction is counterclockwise, the negative direction is clockwise. So measure off an angle of positive pi over 4, which is over here, right? And then you go 2 units from the origin. 1, 2. See, that's why you have all these concentric circles, because then that can tell you how far you are from the origin. And that's why they label all those angles for you. Okay, let's keep on going. You just got to get used to this. What about 3, 2 pi over 3? Measure off an angle of 2 pi over 3, which is 120 degrees, which would be about there, right? And then go 3 units from the origin. 1, 2, 3. There's the point. Okay, we just keep on doing it till you get it. How about 1 comma pi? Measure an angle of pi, positive pi, so go clockwise pi, 180 degrees, that's over here, and then go 1 unit from the origin, boom. See how you go 1 unit in the direction of that angle? So you gotta stop thinking rectangular coordinates, you gotta think polar coordinates now. Now, what would happen, okay, let's do some negative degrees. What about negative angles? What about 2 comma negative pi over 2? So measure off an angle of negative pi over 2, so that means go clockwise 90 degrees. And in that direction, you go 2 units. So 1, 2, right there. So you have to go that many units in this direction. Okay, what about 3 negative 3 pi over 4? So measure off an angle of negative 3 pi over 4, so you have to go clockwise 135 degrees, which is over here, and then go 3 units from the origin. 1, 2, 3. And then now, what would happen if r is negative? So how about something like this? Negative 3 pi over 2. So measure off an angle of pi over 2, positive, so go clockwise 90 degrees. And then what do you think you're going to do when r is negative? You go 3 units in the opposite direction. So 1, 2, 3, it's going to be right there. So whenever r is negative, you have to go the opposite direction of this angle. Okay, so what would happen if both of them are negative? How about negative 1, negative pi? So measure off an angle of negative pi. So go clockwise 180 degrees, that would be here, right? And then you're going to go 1 unit in the opposite direction. So 1 unit is right there. So the first thing you're probably noticing is, oh, so Mr. Park, there's like an infinite number of ways of labeling a point then. Yes. For example, this point right here, I mean, you can pick any one of these. We could label that point 1 comma pi, but couldn't we also label it negative 1 comma 0? Right? Measure off an angle of 0 and then go 1 unit in the opposite direction. What about 1 negative pi? Right? Same thing. What about 1 3 pi? Right? What about negative 1 5 pi? No. Sorry about that. Negative 1 2 pi. Yeah. So every single point in the Cartesian plane, there's an infinite number of ways of labeling it in the polar coordinate system. Whereas in the rectangular coordinate system, there's only one way to label it. But the standard way would be this, like here. R is positive, and this angle is between 0 and 2 pi. That's the standard way. But there's lots of different ways of labeling. All right, now we know how to plot points. So think back when you first plotted points. Pre-algebra, probably, whenever you took pre-algebra. What was the next thing in the progression after you learned how to plot points? You what?
Line?
Yeah, you draw graphs, that's right, Rick, so that's what we're gonna do. And we have a lot of base graphs in the rectangular coordinates, this system, right? We just finished the last of the base graphs, right, the inverse trig functions. You also have base graphs in the polar coordinate system. All right, so I guess the first thing I should do, I gotta scroll. I wish this was a smart board. So, if you look at the top there, you see those formulas? Those are the 4 conversion formulas. Because what you're going to do is you're going to convert back and forth. Oh, this is before we graph. Now, to derive those formulas right there, you basically look at this triangle. Look at this triangle right here. So let's write down the 4 equations. R squared is equal to, using the Pythagorean theorem, x squared plus y squared. Tangent theta is equal to y over x. X equals r cosine theta. And again, remember, if you have a right triangle, if you know the hypotenuse in this angle, how do you get the adjacent side, which is x? Hypotenuse times cosine theta. That's how you componentize the vectors, right? Y, which is this side, is equal to what? R sine theta. These are the 4 formulas you need to know. Okay, you know what? I made a mistake. We're not ready to graph yet. The first thing we have to do is we have to convert from one to the other. So if I give you, so let's do polar to rectangular first. If I give you a polar point like 4, 5 pi over 6, how do you convert that into rectangular coordinates? Well, you could actually draw the graph and then figure it out, but I'm telling you the fastest way is to use these 2 formulas right here. That's the fastest way. So, remember, this is r and this is theta, right? How do you convert this to rectangular? Well, x is equal to r cosine theta. Y is equal to r sine theta. And then now you just have to know your trig values. We still got to know that? Oh yeah, we're going to be using trig throughout the whole year and next year and until you finish your math career. What is the cosine of 5 pi over 6? Negative root 3 over 2. And of course that will simplify to negative 2 root 3. What is the sine of 5 pi over 6? 1/2. And then of course that simplifies to 2. So if you want to convert this into rectangular coordinates, you will get negative 2 root 3, comma 2. To me, that's the simplest way. Now, if you just refuse to remember these formulas, then just draw a picture. Okay? So, what does this mean here? You measure off an angle of 5 pi over 6, which is a 150-degree angle, right? And then you go 4 units from the origin. 1, 2, 3, 4. So if you know this is 150 degrees, and this is 4, can you figure out the coordinates of this point? Yeah, you just make a right triangle. So if this is 150, that's 30, and this is 4. So in a 30, 60, 90 triangle, wouldn't this be 2 and 2 root 3? Right? So that means you got to go 2 root 3 to the left and 2 up. And same thing. You can do it. Okay, so to go from polar to rectangular, the best thing to do is use the formulas. But you really don't have to. You can just draw the picture if you want. Now, what about the other direction? Since we're filming, we got to stay on this side of the board. So how about going from rectangular to polar? Okay, so let me give you rectangular coordinates. How about 3, negative 3? Convert that into polar coordinates. Now, most books will tell you to use these 2 formulas, but I'm going to tell you that's not the easiest way. The easiest way is to draw the picture. So here, let me show you what your book will tell you to do. Use this formula. Okay, so this is x and y. So therefore, if I use the first formula, r squared is equal to x squared plus y squared, which is 9 plus 9, which is 18. Therefore, r is plus or minus 3 root 2. How do I know which one to pick, Mr. Park? Well, it depends. Okay, it depends on what you do here. So to figure out what theta is, you use this formula. Tangent theta is equal to y over x, right? Y over x. So negative 3 over 3, which is negative 1. So the tangent of what angle is negative 1? You can pick 3 pi over 4, 7 pi over 4. There's an infinite number. What about negative pi over 4? Right? There's an infinite number of them. So how do I know which one it is, Mr. Park? Well, it just depends which angle you use. For example, okay, how do you plot the point 3, negative 3? Isn't it over here in the fourth quadrant? So if you pick 3 pi over 4 as your angle, which r do you think I have to pick to get this one? You gotta go negative, you gotta go opposite direction. So that means you would have to go, if you pick the angle to be 3 pi over 4, then you have to pick negative 3 root 2 as your r. Okay, what if you pick 7 pi over 4 as your angle? Well, 7 pi over 4 is there, so don't you just go that much? So then you pick positive 3 root 2. That's just too much work. Look how fast it is if you just draw the picture. So forget this. That's just wasted time if you ask me. Just draw the picture. How do you plot the point 3, negative 3? So if this is 3 and that's 3, how far from the origin are you? Really? Come on, this is a 45, 45, 90 triangle. 3 root 2. And then what is this angle? You can see, 7 pi over 4. So the answer is 3 root 2, 7 pi over 4, right? Because isn't that a 45-degree angle there? Or you could have gone 3 root 2, negative pi over 4, right? Just go pi over 4 clockwise. Or if you wanted to, you could go, oh, I want to go on the opposite side, so 3 pi over 4, negative 3 root 2. Look, you don't have to do any of this work. Just draw the picture. Okay, so let's practice using this technique here. All right, here we go. What about, okay, so convert from rectangular to polar. How about 0, 5? Draw a picture. How do you plot the point 0, 5? Right there, right? How far from the origin are you? 5. What is that angle? Pi over 2 or 90 degrees. I'll take either degrees or radians. I don't care in this chapter. There you go, finish. Okay, let's do one more. How about, okay, gotta think. Negative 4 root 3, 4. Okay, draw the picture. Draw the picture. So if I go 4 root 3 to the left, and then 4 up like that, how far from the origin am I? People, I'll give you a hint. It's a 30, 60, 90 triangle. Look, if one leg is radical 3 times the other leg, isn't that 30, 60, 90? So therefore, shouldn't that be 8? Because the hypotenuse is always double the short leg. Come on, SAT, you know they're going to test you on 30, 60, 90 triangles, right? So it's going to be 8, and then what angle is that? Is that the 30 or the 60 degree angle? That's the 30 degree angle, so therefore, isn't that 150? Or 5 pi over 6? Finished. Draw the picture, but I'm not, if you want to use the formulas like Mr. Rubash taught you last year, then you're certainly able to do that. I told you I didn't do optional things, Mr. Park. Okay, now let me scroll. So now that we know how to plot points and convert from one to the other, and by the way, look, you got all these notes, graphing calculator instructions, examples. Oh, Mr. Parker, read that, I can learn stuff. Okay, this is tonight's homework. So number 1 and 2, you're simply converting. What about 3? Find the distance between two polar points. Oh, darn it, I gave you a hint. You're not gonna get a hint on that first quiz. Okay, let me give you a problem that is just like that. Okay, let me think. Make it a little bit different from the homework. So find the distance between these two polar points. 8, 10 degrees and 5, 70 degrees. Find the distance between these two. So one thing you can do is you can convert it to rectangular coordinates and then use the distance formula, but it's going to come out really ugly. The best way is, well, look, I gave you the hint. Use the law of cosines. We still got to remember that. Okay, how do you plot this point here? You measure off a 10-degree angle and then go 8 units from the origin. 1, 2, 3, 4, 5, okay, let's just say that's 8. Okay? How do I plot this point? You measure off a 70-degree angle, something like that, and then you go 5 units from the origin. Find the distance between those 2 points. Well, if I make a triangle, isn't this 8? Isn't this 5? Do I know the included angle? Well, if this angle is 10 and that's 70, what do you think that is? It's 60. You just subtract, right? Big minus small. Basically subtract the angles. So if you know 2 sides and the included angle, how do you find this? The law of cosines. You're going to be quizzed on it on Friday, right? So remember the law of cosines? If this is the opposite angle, then you start with this, x squared. Have we memorized it yet, or are we going to wait till Friday morning? 5 squared plus 8 squared minus 2, 5, 8. Whatever these two are, you just put it there. Cosine 60 degrees. Yeah, I know that number, Mr. Park. Cosine 60 degrees. 1/2. Okay, so we got x squared equal 25 plus 64 minus, oh, the 1/2 cancels the 2. So what is 5 times 8? 40. So you got 89 minus 40, which is 49. Therefore, x is 7. Well, it's actually plus or minus 7, but distances cannot be negative. So this is 7. So that's how you find the distance between 2 polar points. Use the law of cosine. Okay, next. Okay, now look at number 4. You got a whole bunch of problems. Now there's different ways of plotting polar curves. Did you guys learn how to do that? Who did the optional thing last year? Did you guys actually draw graphs?
We saw this graph. I think
But did you have to like do it?
we didn't have any like homework.
There's no homework.
No. Right?
I don't know. Okay, whatever. Okay, so there's lots of different ways of graphing. Now, if you don't know anything, well, how did you guys learn how to, okay, let's go back to Algebra 1. Or whenever. When was the first time you learned how to draw this graph? 6th, 7th, 8th grade around? And what did your teacher tell you to do? Make a chart like this. You probably went like this, yeah, actually. Okay, what are the y values? Plug it in. 9, 4, 1, 0. Okay, and then you plot the points. So -3, 9. Ang plot at sang si sa dito. Okay, -2, 4. 1, 1, 1. 0, 0. 1, 1. 2, 4. 3, 9. Connect the dots. Oh, I got a pretty U. It's a parabola. Right? That's how we learn to, right? So, I guess when you first learn how to, for example, which one do I want to do? Okay, let's do this one. R equal 4 cosine theta. Now, if you're going to plot points, this is what you got to do. You're going to make a chart like this. And then usually to get a good idea of what a graph looks like, you'll plot a point every 30 degrees, I would say. So 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, and you just keep on going until you get 2 pi. You plot these points, and then you start. Okay, here, let's just try. Okay, how long would it take you to even fill in this chart? A long time. Okay, let's see how far we can go. If I plug in 0 for theta, cosine of 0 is 1 times 4. Okay, plug in pi over 6. Cosine of pi over 6 is root 3 over 2 times 4. 2 root 3. See, look how slow it's going. Plug in pi over 3. Cosine of pi over 3, half times 4. 2. Plug in pi over 2. And then you just keep on filling it in. And then after you finish filling it in, now we can start graphing. Okay, so what does this mean? You measure off an angle of 0, and then you go 4 units from the origin. Right there. Okay? What does that mean? Measure off an angle of pi over 6, or 30 degrees, and then go 2 root 3 from the origin. I think I told you this before. When you graph trig functions, you should know that root 2 is about 1.4 and root 3 is about 1.7. You need to know these things to graph. So if you know root 3 is 1.7, what is 1.7 times 2? Okay, so what you might want to do is you might want to draw the concentric circles like that. Okay, so if I measure off an angle, so what is 2 root 3? What did we say, 3.4? So 3.4 would be about there, right? Okay, measure off an angle of pi over 3, which is 60 degrees, and then go 2 units from the origin. And then measure off an angle of 90 degrees, and then you go 0 units from the origin. And if you connect the dots, you get something like that. But then how long would it take you to do the whole graph? Like I said, it's going to take a really, really long time. So this is called last resort. Yes, we're going to do this, but not until polar 3, I believe. Then you got to get good at that. So there's got to be a better way this year. Yes, there is a better way. So look at that. Okay, I'm going to do a problem just like that. R equal 4 over cosine theta. Instead of making a chart, now think about that. Making a chart, you got to actually divide by radical thingies. That's going to take even longer. So maybe we can convert it to a rectangular equation, and then I can recognize that equation. So you know what? I'm going to put up the 4 formulas again. I shouldn't have erased it to begin with. Tangent theta equal y over x. X equal r cosine theta. Y equal r sine theta. If you go to BC calculus, these formulas have to be at your fingertips. Okay, now what can I do to this equation to use one of these formulas here? Okay, let me point at it. What can I do to this equation so that I will see r cosine theta? Cross multiply. So r cosine theta equals 4. Hey, but hey, you somebody. X equals 4. Hey, I know how to graph that. How do you graph x equal 4? 1, 2, 3, 4. Vertical line. There you go. That's the graph. So this is the polar equation, but can you imagine making a chart like this? That's crazy. You would end up with the same graph anyway. Maybe now is a good time to show you how to graph it on your calculator. Anyway, this is how you're going to check your answers on your homework. So where's the calculator? There it is. Okay, so first apps. Okay, which graphing do you think I'm going to do? Since we're studying polar. Which app am I going to use? The polar app, right there. Click on polar. Okay, let's get rid of this old one. Shift here. Okay, so punch that thing in there. So R equals 4. Where's 4? 4 divided by cosine. Now, how do I get theta? this, you see this button above the tangent button? This is called your independent variable button. If you're in the function app, then the X comes out. If you're in the polar app, the theta comes out. If you're in the parametric app, the T comes out. If you're in the sequence app, the N comes out, but that's your independent variable. So if I press that button, you get the theta. Oh, I guess you could have pressed this button up here too. That's also theta. And then let's right arrow out of this thing. Enter. Now, should I just press the plot button? No, the window. So shift, plot setup. Okay, now I want you to notice something. The theta range goes from 0 to 6.28. That's 2 pi. So if you're in radian mode, 0 to 2 pi is the default. That means once around. So, and then theta step, I believe this is 7.5 degrees. So what your calculator does, it calculates a point every 7.5 degrees, and then it connects it and makes a graph. Okay, well, we can keep this the same, so if you want. So let's press the plot button then. See? You get the vertical line x equal 4. But anyway, that's how you plot any kind of polar curve. Just like that. That's how you punch it in. So that's how you can check your answers, especially some of you forgot some of the graphs, yeah? Okay, let's do another one. So the way that we're going to graph tonight is you're going to convert it to a rectangular equation, and hopefully you will recognize it. Hopefully. Okay, how about r equal 4 sine theta? In fact, we did something like it over there. Okay, what can I do to this equation so that I can use these formulas right here? Because look, r squared, if there's r squared, I can replace that with x squared plus y squared. See, what you want to do is you want to change this equation, get rid of the r's and the thetas, and change it to x's and y's. That's what you want to do. So r squared, how can I get r squared? Okay, I'm going to give you two choices. You tell me which one is better. You can square both sides, or you can multiply both sides by r.
Where?
Okay, let's try squaring both sides. R squared equals 16 sine squared theta. Okay, but see, we got sine squared theta. Is there a formula here for sine squared theta? No, so I don't think that's the one. So what was the second option? Multiply both sides by r. So you get r squared equals 4r sine theta. Hey, you somebody. And then, hey, you somebody. That's y. So 4y. That was the better way to go. And then, of course, you guys recognize this as a
Circle.
circle. Thank you. How did you know it was a circle? Because you took algebra 2, right? Anytime you have x squared plus y squared, and these two coefficients are the same, it's a circle. How do you figure out the center and the radius? You guys better know this for SAT. And ACT, by the way. Complete the square. So you put x squared plus y squared, bring the 4y over, leave a space to complete the square. What do I have to add right there to make a perfect square? You take half of that number and square it. So -2 squared is 4. But remember, you gotta add it to both sides, yeah? So x squared plus y minus 2 squared equals 4. I hope you guys now recognize that as a circle. What's the center? 0, 2, radius 2. Square root of that number is the radius. So if you graph it, the center is at 0, 2. Right there, there's the center. And the radius is 2, so it's going to look like this. Okay, let's try graphing it on your calculator. See what you get. Oh, we're struggling with circles. Okay, so get rid of this one. 4 sine theta. 4 sine. Let's try that theta this time. Enter. Plot. Yep, it's a circle. Now I know probably some of you are thinking, Mr. Park, I'd rather make the table plot a point every 30 degrees. Oh, darn it, I'm not gonna go back. Okay, so easy, medium, okay, let's do a more difficult one, okay? I guarantee one of these, and by the way, when is the last quiz? Before Christmas break? I think it's, I don't know, next week sometime. Okay, let's do a conic section. So there's the last 3 problems, you're gonna have ellipse, parabola, hyperbola. Now, I don't expect you to like find all the parts, like the full side, remember that? I don't expect you to do that. I just expect you to draw the graph. That's all I do. Because the first chapter in the 3rd quarter, then we're gonna study the conic sections. Then you're gonna have to find the full side, the directrix, remember that? That's also gone from one. Okay, R equal, okay, let me think. It depends what we want. What do you want? Parabola, ellipse, or hyperbola? I think we better go with hyperbola because that's probably the one that's gone from your mind, yeah? Okay, if we want a hyperbola, how about 3 minus 2, let's do a cosine one, and then we got 135, so let's put a 15 up there. Except that's so dumb. Sometimes I don't think. Now that's a hyperbola. You don't know it, but I know it. Okay, so you can plot a point every 30 degrees, but we're not going to do that. We're going to change it to a rectangular equation. Any ideas? What do I have to do to change this to rectangular? What can I do to use these formulas here? It rhymes with Haas multiply. Thank you. Cross multiply. So you get 2r minus 3r cosine theta equal 15. Hey! You somebody. See, you want r cosine theta and r sine theta. What is that? X. That's x. Okay, did I change it to a rectangular equation yet? No, because I still got an r there. So what do I do? Okay, why don't I just tell you? Isolate the r term and then square both sides because you want r squared because r squared is x squared plus y squared. So square both sides. I think I better do this. 4r squared equals 9x squared plus 2ab, 9x plus 225. And then what is r squared equal to? X squared plus y squared. So if you distributize the 4, 4x squared plus 4y squared equals 9x plus 90x plus 225. Do you guys remember how to put ellipses and hyperbolas into standard form? Or is that just gone from the memory too? Okay, so what you gotta do is, okay, it doesn't matter what you do. Okay, why don't we put all the x's and y's on this side? So subtract 4x squared. You have 5x squared minus 4y squared plus 90x, and then bring the number on this side. Now, how do I know, just by looking at these 2 terms right here? Your teacher should have taught you this last year. How can you tell what it's going to be? If these 2 numbers are the same, it's a circle. We just did it over here. See the 1 and 1 are the same? If these 2 numbers have the same sign, but they're different, then it's an ellipse. And if these 2 numbers have opposite signs, then it's a hyperbola. Okay, so how do I put it in standard form this year? Okay, here's your x terms. What can be factored out? Factor out the 5, so you get x squared plus 18x, leave a space to complete the square, minus 4y squared. What do I have to add right there to make a perfect square? You take half of that number and you square it. What? Okay, 81. But what did I actually add right there? I added 5 times 81, which is 405. That means you have to add 405 to both sides now. Okay, so this is what you got so far. I think we're going to have to erase. We need more room. Okay, so this is what we got so far. 5 times x plus 9 squared minus 4y squared equals 180, okay? Now, remember, to put an ellipse or hyperbola in standard form, what do we want this side to be? You gotta remember this at least. You want it to be 1. Okay, so how do I get the 1 there? I'll give you 2 options. Subtract 179 from both sides, or divide both sides by 180. Yeah, that's the one you want. Okay, divide both sides by 180. So do this. 180, 180, 180. So what do we got? I'll bring it down more. So x plus 9 squared over 36 minus y squared over 45. See, if this sign in the middle is a minus, it's a hyperbola. If it's a plus, it's an ellipse. Oh boy. Like I said, all I expect is you can graph it. That's all I expect. You don't have to find anything, just graph it. What is the center of this hyperbola? Just like circle, just look at it. -9, 0. So -9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we're going to need more. We're going to erase. This is the center. Now, the square root of that number, which is, what does that tell you? That's how much you go left and right from the center, because it's under the x, right? X is left and right, y is up and down. So what you do from here, you go 6 to the left, and then 6 to the right. 2, 3, 4, 5, 6. Okay? Now, the square root of that number tells you how much to go up and down from the center. What is the square root of 45?
35.
Is it 3 point something, 4 point something? Tell me when to stop. 5 point something, 6 point something, 7 point something, 8 point something. I already went past it. 6 point something. Because 7 squared is 49 already. So 6 point something. 1, 2, 3, 4, 5, 6, 7. So about there and there. 1, 2, 3, 4, 5, 6, 7. About there. Now, if this was a plus sign, then you just make an ellipse out of it, right? But since it's minus, it's a hyperbola. So you remember what you did last year with these points? You make a rectangular box. And then what do I do with this box? The diagonals are the asymptotes. And then if the x comes first, is this a hyperbola, a left-right one, or an up and down one? 50-50 chance. If the x comes first, it's up, left and right. If the y comes first, then it's up and down. So which one is this? It's left and right. And here's Johnny. That's all I expect you to do. I don't expect you to find, what do you call these points? Let's see if you guys remember anything. What are these 2 points called? The vertices. What are these 2 points called? The endpoints of the conjugate axis. What are these 2 points called? The foci. What are these 2 lines here called? The directrices. What are these 2 segments here called? The lateral recta. That's plural for latus rectum. Yes or no? You guys learned latus rectum last year. So no, how come you guys know what is he talking about? You don't have to know any of that. You just got to be able to draw the graph, okay? Third quarter, the first chapter is we're going to be able to find all the parts of it. Oh boy. Okay, so this would be an example of a hard problem. So you're gonna get 3 of them. On the quiz, I'm only gonna give you 1. I'll tell you right now, it's either an ellipse or hyperbola. Write that down somewhere. Okay. Oh, that took longer than expected. Okay, the bell's gonna ring in 5 minutes already. So, I gave you the 8 problems now. Make sure you know how to do that. So this is a 60-point quiz. Okay, let's just set the ground rules. So, let me think. 8 problems, so 7 points each, and I give you 4 free points? Or should I make it 6 points each, and I give you 12 free points?
12 free
Or should we go 5 points each, and I give you 20 free points?
points. Yes.
I'm not gonna give you 1/3 of the test free. I gave you the problems. I think this is the one. So the most I take off is 6 and you get 12 free points. I think that's good. Okay, we'll see you Friday. And if you cannot figure out how to do those 8 problems, then maybe you're gonna come in for help or something.